Okay, so two sections today. We're gonna start with 8.1, and I made a mistake on the schedule. We need to do 8.7, not 8.6. But anyway, we'll start with 8.1, and this section is something about sequences and series. Let's just do some pattern or some examples. So, like for example, number 1, it gives us something like this. It says an is equal to 4n minus 1, and basically what this means is, so we could plug in letters for n, numbers for n, like 1, 2, 3, 4, 5, whatever. So if we plug in a 1, all it means is we plug in 1 for n. So this is going to be 4 times 1 minus 1, which is just 4 minus 1, which is 3. We could plug in 2, so a2 is just 4 times 2 minus 1, which is 7. So it's basically like a function. You plug in a number and you get a number. We can plug in a3, so this is going to be 4 times 3. So all we're doing is plugging in 3 for n. So in this situation, whatever goes down here, this number, we just plug it in right here. So 4 times 3 minus 1, which is 11. This problem in particular, well, we're not going to go up to, so it tells us to find a10. Oh, we could do that. So find the first 4 terms. That's what the instructions say. So find the first 4 terms, then find a10 and a15. So a4, that's going to be 4 times 4 minus 1, which is 15. And then it tells us to find a10. So a10 is, all we do is plug in 10 for n. So 4 times 10 minus 1, which is 39. And then a11 is, or sorry, a15. 4 times 15 minus 1, which is 59. Okay, and how about number 8? So here, let's do the same thing. So it's given to us that an is minus 1 to the n minus 1. And then 3n minus 5. So a1, this is going to be minus 1 to the 1 minus 1. 3 times 1 minus 5. So minus 1 to the 0 is 1. And then we have 3 minus 5, which is minus 2. And a2, minus 1 to the 2 minus 1. 3 times 2 minus 5. So minus 1 to the 1 is minus 1. And then we have 6 minus 5, which is positive 1. So minus 1 times positive 1 is negative 1. A3. So minus 1 to the 3 minus 1. 3 times 3 minus 5. So we have minus 1 squared, which is positive 1. And then 9 minus 5, so just 4. Then a4. So minus 1 to the 3 is negative 1. And then we have 12 minus 5, which is 7. So negative 1 times 7 is minus 7. And a10. Minus 1 to the 9 is negative 1. Then we have 30 minus 5, which is 25. So negative 25. And a15. So negative 1 to the 14 is positive 1. And then we have 45 minus 5, which is 40. All right. 11 through 18, those are like the same problems. All right, so let's do a couple examples from like 19 and on. So for these ones, what we want to do is we want to figure out, so before we were given the pattern is this thing, an is equal minus 1 to the n minus 1, 3n minus 5. So suppose like we were just given these numbers. We want to figure out how to find this part then. So like kind of work backwards. So how we kind of do that is really not a method. It's just sort of just like we have to look at it and like kind of like do some guess and check. So if we start with 19, we're given this sequence. This one's not too bad. This is 2, 4, 6, 8, 10, so on. We want to find the pattern. So basically we want to know, what does an equal? So like, what is the nth term? Well, so right here we have, here's the first term, the second term, the third, the fourth, the fifth. So basically the first is 2, the second is 4, the third is 6, the fourth is 8. So basically this is what we need. We need a 1 to be 2. We need a 2 to be 4. We need a 3 to be 6. We need a 4 to be 8. We need a 5 to be 10. So we got to know, okay, what is the pattern? Then what does an equal? Well, it's kind of, we can see it, all we're doing is just multiplying by 2. Like this right here, this is just 2 times 1. This is 2 times 2. This is just 2 times 3. This is just 2 times 4. So we see the pattern quite easily for this one. This is 2 times 5. So an is just 2n. Let's do 21. Number 21, we have minus 2, 6, minus 18, 54. Okay, so for this one, we're going to need a 1 to be minus 2, a 2 needs to be 6, a 3 needs to be minus 18, a 4 needs to be 54, and so on. So we want to know, what is an? Well, we see this thing, goes minus, plus, minus, plus, minus, plus. So we know this is, the first one's minus, so it's going to be minus 1 to the n. Or sorry, we'll do minus 1 just to the 1. So this is just the first part. This one then would be minus 1 to the 2. This part would have a minus 1 to the 3. This part would have a minus 1 to the 4. Because minus 1 to the 1, this is negative, this is positive, this is negative, this is positive. So that's how we take care of the positives and the negatives. So now what's going on? Well, we have 2, then 6, then 18, and then 54. So basically it's like we have, let's see, 2. So like 2, this could be 6. Let's see. So we can write this. This is sort of like, so 2 can just be written as, we'll put a 2 here. 6 is going to be 2 times 3. 18 can be 2 times 9. And then 54 is 2 times 27. But then what we can keep doing here, this is going to be minus 1 to the 1 times 2. This is going to be minus 1 to the 1, or sorry, minus 1 to the 2, 2 times 3. Then we have minus 1 to the 3, 2 times 3 squared. This one is minus 1 to the 4, and then 2 times 3 to the 3. So notice how, and we can write here, this is sort of like 3 to the 0, because 3 to the 0 is just 1. So basically we have this piece, and then we'll have 3 to the 1, or sorry, 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, and that keeps going on forever and ever. So with that pattern, we see then that our an term, well, when this is, so notice when this is a 1, we have a 1 right here. And this is a 2, we have a 2 right here. And this is a 3, we have a 3 right here. When we have a 4, then there's a 4 right there. So then our minus 1 should just have an n. So minus 1 to the n. We always have a 2. Then we have a 3. So notice now when this is a 1, we have a 0. This is a 2, we have there's just a 1 up there. 3, we have a 2. 4, we have a 3, so it's always 1 less. So if we have an n for like, a to the n, the piece up there we should have is an n minus 1. How about the rest aren't crazy bad. Let's see. What are the problems in here? I guess let's get into for sequences. So the next thing that we're going to talk about is something called a sum. And so sort of the notation is, what a sum means, you add up a bunch of numbers together. So we have this notation. Let's write it like this. So we usually write like, say, a equals 1 to k of an. And what this means is we're going to do a1 plus a2 plus a3 all the way up till we get to ak. So this just tells you where you start at, and this tells you where you're going to finish at, and you add up everything in between. So just like a quick little example. Say if we wanted to calculate the sum 1 to 4 of n over, say, m plus 1. But this is going to equal then, so we start with 1, so we're going to get 1 over 1 plus 1. Then we do 2, so 2 over 2 plus 1. Then we do 3, so 3 over 3 plus 1. Then we plug in 4, so 4 over 4 plus 1. So we end up getting here, this is going to be 1/2 plus 2/3 plus 3/4 plus 4 over 5. And this would be our answer. Sure, you get a common denominator, but we don't need to do that. So basically, that's just what this notation means. So if we have this, it just tells us you plug in the numbers and from the bottom one, so from n equals 1 all the way up to 4. And I guess another thing, so with this notation in mind, something called a partial sum of a sequence or a partial sum of a series. So partial sum of a sequence. So what this means is, so say if we're given a sequence, a1, a2, a3, an, maybe it goes on forever. So we just have like this pattern of numbers, and we don't know the partial sum. So the partial sum is normally denoted by this s with like an n or a letter on the bottom, n. Let's use, that's fine, n. So basically with this, or let's actually use a k, just to stay consistent with above. So if we want to find the partial sum, so say like of this series, sk, what this means is we just add up the first k elements. So this is really going to equal the sum, n goes from 1 to k of an. So a partial sum is just when you say sk, that just means we add up the first k pieces of our sequence. So a quick example of this one is, so say if we have a sequence, say something like 1, 3, 5, 7, 9. And when we see all we're doing here is we start with 1 and we keep adding 2. Or 11, so 13, this goes on and on. So we want to know, maybe what we can do here is we can do two things in this problem. First in this, let's find a general form for an. And also let's find, say, how about S4 and S9. So let's add up the first 4 and then we'll add up the first 9. So first let's start with finding a general formula. So let's see, what do we have here? Well, we know that A1 is 1, A2 is 3, A3 is 5. Let's just do one more. So A4 is 7. And we don't know, okay, so what does AN equal to? So what is this? Well, this is 1, which we can write as 1. But this is going to be, 3 could be written as like 1 plus 2. 5 can be written as 1 plus 4. 7 can be written as 1 plus 6. So we kind of see a pattern. We're always doing this, and this 1 can be written as 1 plus 0. So we're always doing a 1, then we're doing 0, 2, 4, 6. So just 2, 4, 6, adding up all the even numbers. So another way we can write this so we can kind of see a better pattern. So this is going to be just, we can say 1 plus 2 times 0. 1 plus 2 times 1. 1 plus 2 times 2. This is 1 plus 2 times 3. So now we can see what AN is. There's always a 1, so 1 plus, and there's always a 2. And so let's see what goes on here. Well, when we have a 1, there's a 0 here. When we have 2, there's a 1 here. 3, there's a 2 here. 4, there's a 3 here. So it's always 1 less. So if we have an n, there should be an n minus 1 here. All right, so then this is going to be our formula for AN. Our AN is equal to this piece. All right, so that takes care of the first part of the problem. So now let's find S4. So remember S4, this is just the sum. N goes from 1 to 4 of AN. So we're adding up the first 4 terms. So again, this is going to be A1 plus A2 plus A3 plus A4. We know A1 is 1, so plus A2 is 3, A3 is 5, and then A4 is 7. So we just have 1 plus 3 is 4, plus 5 is 9, and plus 7 is 16. Okay, and so then S9, so there's S4, and then we want to find S9. Well, this is just the sum as n goes from 1 to 9 of an. So A1 plus A2, A3, all the way up to A9. So what's this going to equal? So we already said A1, that's going to be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So how many is that? It's 1, 2, 3, 4, 5, 6, 7, 8, and one more. So plus 17. And so you need a calculator or whatever, and you add it up. But this is just going to be what S9 is equal to. All right. Do a couple more examples. How about something like, I mean, they're all kind of the same from this point on. Let's do one more of those sum ones together. Maybe 40. So we just want to calculate I equals 1 to 5, I minus 1, I plus 3. Okay, so we start when we plug in I at 1, so when we plug 1 all the way up to 5. So what this is going to equal, then starting by plugging in 1, we're going to have 1 minus 1 over 1 plus 3. Then plug in 2, so 2 minus 1 over 2 plus 3. Then plug in 3, so 3 minus 1 over 3 plus 3. Then we plug in 4, so 4 minus 1 over 4 plus 3. And then plugging in 5, 5 minus 1 over 5 plus 3. So again, remember, we're plugging the numbers for I here. So this is saying I goes from 1, and we stop at 5. So here's, 1, then we plug in 2, then we're plugging in 3, then we're plugging in 4, and then we're plugging in 5. All right, so what does this all equal? So the first one is 0 over 4. Next one is 1 over 5. Then we have 2 over 6, then 3 over 7, and then 4 over 8. I'm just simplifying a little bit. 0 over 4 is 0. Then we just have 1 over 5. 2 over 6 is 1 over 3. 3 over 7. And then 1/2. So again, you can get a calculator, just get a common denominator, combine all those together. So that'll be our answer for 40. All right. So the next bit, let's kind of like work backwards for these sum ones. So let's let's do 53. So what we want to do is we want to write 2 minus 4 plus 8 minus 16 plus 32 minus 64 in sum notation. So sum notation meaning we want to turn it into this. So what we can think of this is that we're adding up all these numbers. So what we can do is basically what we're doing, we can rewrite this sort of like we're doing 2, then we're doing plus -4, we're doing plus 8, and then we're doing plus -16, and we're doing plus 32, and then we're doing plus -64. So what we want to do is so we're given here 1, 2, 3, 6 terms. So when we do this, we want to do sum and goes from 1 to 6 of an. So what we need to do is really find our an. So this is kind of like our a1, here's a2, here's a3, here's a4, here's a5, and here's a6. So how can we find the pattern? Well, we know that a1, that's just going to be 2. And we see how it goes plus, minus, plus, minus, plus, minus. So we're starting with a plus. So that means let's start with let's do that, take care of that thing first. So our first bit is here we're going to have a -1 to the 2 because that gives us a plus sign. So we're just going to put that there. So then times 2. So a2 is a minus sign. So then we can do -1 to the, say, 3 because -1 to an odd is a negative. And then we have 4. So we can write that as, maybe 2 squared. A3 is positive, so we can do minus 1 to the 4. And then we have 8, which is 2 to the 3rd power. We know that A4, so A4 is minus 16, so we're going to do minus 1 to the 5. That gives us a negative. So notice how we keep counting up, 2, 3, 4, 5. So that leads us to believe that it's going to keep happening. And then 16 is 2 to the 4 power. And then A5, well, it's basically, we kind of already know the pattern here. So all we're looking to do is find AN. So you see when this is a 1, we have a 2, and this is a 2, we have a 3. So it's always 1 extra. So this is going to be minus 1 to the n plus 1. And then also, so when you have a 1 here, there's a 1 power. 2 here, we have a 2 power. 3 here, we have a 3 power. So whatever the subscript is on the n, that's going to be our power. So now we have an n, so this is just going to be 2 to the n. So then here's our an term. So we said we wanted to find this sum. So basically what we can say then is our sum is actually equal to this. Sum n equals 1 to 6, minus 1 to the n plus 1, 2 to the n. All right, how about we could do 54 as well. So 54, we want to write 3 plus 6 plus 9 plus 12 plus 15 in sum notation. Or sometimes it's referred to as sigma notation. So sigma notation. These two things mean the same thing. Okay, so what do we have here? Well, our first, again, this is like we're just doing 3 plus 6 plus 9 plus 12. So it's like what we want to find is this. So we have 5 terms. So n goes from 1 to 5 of an. We know that our a1 is 3, our a2 is 6, a3 is 9, a4 is 12, a5 is 15. So what is this? Well, this is just 3 times 1. This is just 3 times 2. That's 3 times 3. This is just 3 times 4. And that's 3 times 5. So then what we can kind of just easily see here that our an is going to be 3 times n. So our sum right here ends up equaling just this. So 1 to 5 of 3 to the n. Or sorry, 3 times n. All right, how about 59? So let's do the same thing. So so this one is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. And this goes on forever and ever. So we're going to write this in sum notation. So what we have here, a1 is equal to 1 over 1 times 2. a3 is equal to 1 over 2 times 3. Our that's a2, sorry. Our a3 is equal to 1 over 3 times 4. Okay, so now what's an? Well, what we kind of can see going on down here is we have 1 and then 2, and then 2 and then 3, and 3 and then 4. So it always starts with this. It goes 1 and then maybe 1 more. So you go 2, then 2, 3, 3, and then 3, 4. So if we start at n, it's going to be 1 over n and then n plus 1. So we want to write this whole sum in sum notation. So basically, we have infinite number of terms. So what we want is we started at the first term and we're adding up infinite number of them. And we just found that our an is 1 over n times n plus 1. So this is just going to be the sum of n goes from 1 to infinity of 1 over n times n plus 1. Okay. The last question from this section, so a recursive sequence. So this one, like 61, it's given us this. We're given that A1 is 4. I'm sorry. And also that AN plus 1 is equal to 1 plus 1 over AN. And here this is going to be N is going to be 2, 3, 4, and so on. So what does this mean? Well, let's just see what happens when we plug in 1. Well, we're already given to that. A1 is equal to 4. So what happens if we want to do A2? Well, if we want to find A2, we're going to use this one, and we're going to plug in N is equal to 1, because on the bottom here, we would have 1 plus 1, which is 2. So then if we're plugging in N to equal to 1 right here, this is going to be 1 plus 1 over A1, which is 1 plus 1 over, and we're already given A1 is 4. So this is going to be 5 over 4. So there's our A2. So now let's do that same thing with A3. So if we want to find A3, well, it's like we want to plug N equals to 2 right here, because we'd have 2 times 1 is 3. So if we plug N equals to 2, this is going to be 1 plus 1 over A2, which is 1 plus, so A2 is 5 over 4, so 1 divided by 5 over 4, which equals 1 plus 4 over 5, which equals 9 over 5. So there's A3. And then let's do it for A4. So how do we do A4? Well, just doing the same thing as before. Oops. A4, let's erase this. So A4, now we want to plug N equals to 3, because then we have 3 plus 1, which is 4. So if we plug N equals 3 now, this is going to be 1 plus 1 over A3, which is 1 plus 1 divided by 9 over 5. Because A3, we just found that that's 9 over 5. So 1 plus 1 over 9 over 5, that's going to equal 1 plus 5 over 9, which is equal to 14 over 9. Okay, so then here's the, so from this we get the first 4 terms are going to be 4, 5 over 4, 9 over 5, and 11 over 9. Let's do one more like that. How about 65? So we're 65, we have A1 is 2, and then we have A2 is 3, and we have AN plus 1 is AN plus AN minus 1, and now we're going to start this one at 3, 4, 5, and so on. So what are, let's see, what do we have of the sequence? So let's do the first 4 terms again. So we're given that A1 is equal to 2. We're given that A2 is equal to 3. Now, how do we find A3? Well, with A3, oh, sorry, this is, if it's N plus 1, we have to start here at 2. So if we plug it, that means like we want to plug in N equal to 2 here, because we'd have 2 plus 1 is 3. So if we plug N equals to 2 there, we're going to get AN plus A1. We plug a 2 in here and then a 2 right here. All right, but we're given what A2. We're given what A2 is, that's 3, and we're given what A1 is, that's 2. So this is going to be equal to 5. So A3 is equal to 5. So now how do we find A4? Well, we do the same thing. Now what we want to do is plug a 3 right here, because we have 3 plus 1, which is 4. So we're going to get a 3 right here, which is A3. Plus, and then put a 3 right here, which is A2. So we just found A3. A3 was 5. And we're given A2. A2 is 3. So that's going to be equal to 8. So then these terms right here, these are the first 4 terms of the sequence. Okay. That's good for this section. So let's move on to section 8.7. So we're going to do 2 things in this section. One thing is the binomial theorem, and the other thing is the Pascal's triangle. And the whole goal is, so we want to do something like this. We want to basically FOIL out something like this, maybe 2x minus 3y to the fourth power. But we want to do it quickly. We don't want to do, basically before the section, the way we'd have to do this is something like this. We'd do 2x, 3y, 2x, 3y, 2x, 3y, 2x minus 3y, so 4 of them, and we have to FOIL everything out, so it'd take a long time. But what we want to do is we want to do this a little bit quicker. And so the first method we're going to talk about is Pascal's triangle. So first, let's draw the triangle. You always start with a 1, a 1, and a 1. And then you're going to put a 1 here. And then you add up these two numbers right above it. So 1 plus 1 is 2. So we'll put a 2 here, and then you always put a 1 on the outside. Again, 1 on the outside. 1 plus 2 is 3. 3 plus 1 is 3. Then put a 1 on the outside. 1 on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then a 1 on the outside. And then, so 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then a 1 on the outside. And so I'm going to write this off to the side. What this corresponds to is a plus b to the 0 power. This is going to be for a plus b to the 1 power. A plus b to the 2 power. A plus b to the 3rd power. To the 4th power. And then this is going to be for a plus b to the 5 power. So what I mean by that is these numbers, what they represent are, so say if we want to just, let's look at a plus b to the 4th power as an example. Or let's go through a couple of these. Let's start with a plus b to the 3. So what this tells us is a plus b to the 3 is so how we do this is so we're going to start with this 3 up here. We're going to write a to the 3. And the number in front of a to the 3 that we're going to write is we look over this column that has an a plus b to the 3, it's going to be a 1. So we technically are supposed to put a 1 right here, which we don't necessarily need to because 1 times as itself. And then we're going to put a b to the 0. So I'm going to write this out and then we'll talk about the pattern. So the next one we have is we write our next number, which is a 3. Let's not put the underline, that makes it a little confusing. We'll put a 3. And then we count down with 1 power on the a, so it's going to be a to the 2. And then we add up 1 power on the b, so b to the 1. Plus, and then we write our next number. Count down 1 more with the a, so now it's a to the 1. And count up 1 more with the b, so it's going to be b to the 2. Then write our next number. Count down with the a, so a to the 0, and count up 1 more with the b, so b to the 3. So if we were to simplify this, we'd have, this is going to be a to the 3, 3a squared b, 3ab squared, plus b cubed. So you see the pattern is you always start with your, so for example, now let's find a plus b to the 5. You always start just by writing this first number, 1. Then the first thing in here you do to this power. So a to the 5, and then you always do b, the other one to the 0 power, b to the 0. Plus, then we write our next number, 5. Count down 1 with the a power, so now it's a to the 4, so we count down. So up here we had 3, 2, 1, 0, and then b counts up, 0, 1, 2, 3. Okay, so we counted down right down here. We had a to the 4. So now we're going to have b to the 1. We count up with our b. Then we write our next number, 10. So count down with the a, count up with the b. Write our next number, again, as a 10. We have a to the 2 plus b to the 3. Write the next number, which is 5. Count down with the a to the 1, b to the 4. Write the next number, which is 1. Count down with the a and count up with the b, so b to the 5. So if we were to simplify this, this is just going to be a to the 5, 5, a to the 4, b, 10, a to the 3, b squared, 10, a squared. Oh, sorry, there shouldn't be a plus sign right here. B cubed. Let's move this over so we can write it all in one. And then we had our 5ab to the 4, and then b to the 5. So put a box around this one as well. Okay, so that's basically the pattern, how we can simplify these. So let's erase all these circles. So for example, let's say if we wanted to find something like this. 2x minus 4 to the third power. So above we were doing, we have our a plus our b. So it's kind of maybe a little helpful to write a plus sign on the inside. So let's just rewrite this inside as 2x plus minus 4 to the third power. So now this is sort of like above, this is our a, and this is our b. So if we want to find a plus b to the third power, we can sort of just use this formula up here, or we can just do our Pascal's triangle again. So what this is equal to, so we look at, so this is to the third power. So we go up to our Pascal's triangle and we look at our third row. So this is for 0, this is for 1, this is for 2. This one's for 3. So this is the row that we're going to look at. So we start, the first number we see in Pascal's triangle is 1. So we were at a 1. Then our first term in here, a, which is 2x, that goes to the third power. And our second term, which is minus 4, that starts always at the 0 power. Okay, so now the next term, plus. So our next number in Pascal's triangle is 3, so we put a 3. Then we have 2x, we count down. So before it was a power of 3, now it's a power of 2. And minus 4. Before it was a power of 0, now it's a power of 1. Plus, the next number in Pascal's triangle is 3, so we put a 3. Then we have 2x, count down. So 1, minus 4, count up. So it's going to be 2. Plus, the next number of Pascal's triangle is a 1. So now we're going to have 2x, count down. So now it's going to be 0. Then minus 4, we count up. Now it's going to be 3. So simplifying this, so we have 2x to the third power, 1, and minus 4 to the 0. So that's just 2x to the third, which is 8x cubed. So now we have, here's a minus 4 and a 3, so that's minus 12. But also, so let's write everything out. So we have minus 12. Then we also have a 2 squared, which is 4, and then an x squared. Okay, so now we have 3 times positive 16. I need a calculator. I think it's 48. Let's see, 3 times 16, 48. So we have a plus 48. Then there's a 2 to the 1 power, so that's just a 2. And then an x. And then now we have 4 to the 3. So let's see, 4 times 4 times 4. 4 to the 3. Oh, but it's minus 4 to the 3. So we're going to get a plus. So we'll have a negative 64. And then 2 to the 0 is just 1, and then times. So basically that's all we have for that last term, because we have 1 times minus 64. So what do we have here? We have 8x to the third minus 12 times 4, so minus 48 x squared. 48 times 2, which is 96 x, and then minus 64. Okay, so that's how we can use Pascal's triangle to find that. We can do, I guess, one more together. Let's do or let's do a different one. How about x plus 2y to the fourth power? Okay, so we're looking for the fourth power. Let's just draw out the triangle again real quick. So we have 1, 1, 1, 2, 1, 1, 3, 3, 1, 4, 6, 4, 1. And this is for a 0 power, a 1 power, a 2 power, a 3 power, and a 4 power. So ours is a 4 power. So the row that we're going to look for is this row. Okay, so we already have a plus sign in the middle. So this right here is just going to be our A, and this right here is just going to be our B. So we always start with the first number of Pascal's triangle, which is 1. Then our first thing, A. So we're starting with the fourth power, so a 4. And then B, which is 2y, and then we always start with a 0. The next number of Pascals is 4. So then we have x, count down, 3, 2y, we count up, 1. Then we have 6. Then there will be an x squared and a 2y squared. And the next number of pascals is 4. So then we count down with the x. So now it's going to be x to the 1. Count up with the 2y to the 3. Then our last number of the row of pascals is 1. And then we have x to the 0. Oh, sorry, not a plus sign. 2y to the 4. So again, notice that we have, here's a 1, 4, 6, 4, 1, and that's this number, 1, 4, 6, 4, 1. Okay, so now let's do some simplifying. The first term is just x to the 4th, because anything to the 0 power is just 1, so we have 1 times x to the 4th times 1. The next one, what we have is, so 2 times 4 is 8, x to the 3, and then just a y. So the next one we have, those are 2 squared right here. So 2, let's write that a little bit neater. We have a 2 squared, which is a 4, and then a 4 times 6, which is 24. Then we have an x squared and a y squared. So the next term, we have a 2 to the 3, which is 8. 8 times 4 is 32. Then we have an x and a y cubed. And the last one, we have a 1, x to the 0 is 1, 2 to the 4, so 2 times 2 is 4, 16, and then y to the 4. Okay. Let's see, what else do we have? Let's do one more problem together from this section. So I said, I mean, let's see. There is another way to do these. I believe this way is actually faster. You know what? Yeah, we'll just stick with the binomial theorem. I'm sorry, the Pascal's triangle. As far as this class goes and this section goes, I feel like this is the easiest way to answer these problems. We'll skip some problems from the section I don't think are too important. I think the Pascal's triangle is a much quicker way. Like if I was going to do this problem, I didn't have a calculator, I would always use Pascal's triangle. The binomial theorem helps if this is, you know, like maybe a 20th power or something crazy like that, but that's not too important. So let's just stick by doing Pascal's triangle. So let's do one more example. Let's do about 37. So we want to expand 3 plus I to the 5th power. And here I is the square root of -1. Expand means what we've just been doing. Expand means turn something like this and write it all the way out like that. Okay, so now we're doing a 5th power. So again, it's always helpful. Let's just keep writing out the triangle. So we have 1. So let's see, 0, 1, 2, 3, 4, 5. Okay, so the first row is, this is always for n is equal to 0. This is for our, and n meaning our power. So here's n's 1, n is 2, n is 3, n is 4, n is 5. So our n right now, the power, it's 5. Okay, so what we want is this row. Our piece up here, so we have, again, let's rewrite it, 3 plus I to the 5th power. So there's a plus sign in the middle, so this is just our A. Here's our B. Actually, let's make this problem a little bit different. Let's turn this into a minus sign. Just so we can add an extra step in here. So this is just some random example now. So remember how we want to have a plus sign in the middle. So let's rewrite the inside. This is the same thing as 3 plus negative I to the 5th power. Okay, so now we have our A and we have our B. So we're going to start doing Pascal's triangle. So the first thing in the row, 1, so we write down a 1. then it's always the first piece to the power, so 5, the second piece to 0, plus the next number, which is 5. Then we have 3 count down now. So now it's 3 to the 4th, and then the other one we count up, so 1. Then we have a 10. 3 to the 3, minus I to the 2. Next number is another 10. 3 to the 2, minus I to the 3. The next number is 5. So 3 to the 1, minus I to the 4. And the last number is 1. Then 3 to the 0, minus I to the 5. Okay, so now let's do some simplifying. So the first number, so anything to the 0 is just 1. So this part right here is 1, then we have 1. So all we have is 3 to the 5th power. So what's that? So 3 times 3 times 3 times 3 times 3 is 243. And so now we have a minus I to the 1, so there's a minus sign. So we have basically right here, this is going to be minus 5 and then 3 to the 4, which is 81. And then we have an I. Plus, so we have a 10 and 3 to the 3, so 10 times 27. There's a minus sign squared, so the minus sign goes away. And then we have I squared, which we know is minus 1, but we'll do that in the next step. Okay, plus now we have, oh, this is going to be a minus sign now, because see how we have a minus 1. So there's that minus I to the 3rd power. So that minus sign is going to stay. So we're going to have minus 10 times 9, and then I cubed. So now we have a minus I to the 4th for the next one. So the minus sign goes away. So we just have 5 times 3, which is 15. And then I to the 4th. And then, so 1, 3 to the 0 is 1, and minus, so we have a minus sign to the 5th power, so we're going to have a minus and then I to the 5. Okay, so now we need to simplify this. So what do we have? The first term, that's just 243. Now we have 5 times 81, 405, so minus 405. And we leave that the same. Okay, so now we have 10 times 27, so 270. I squared is minus 1. So now what we need to simplify really is this: I cubed, I to the 4th, and I to the 5. So let's do that down here. So I to the 3, we can write this as just let's do this a little bit lower so we make sure we have enough room. I cubed, we can just rewrite this as I squared times I. We know I squared is minus 1, so this is just minus 1 times I, which is equal to minus I. So when we have I cubed, so on this box right here, I cubed is just minus I. So we have minus 10 times 9, which is minus 90, but then there's also another minus sign. So this is going to be, actually, we can write this. So let's do this. We'll have minus 90. And then I cubed is minus 1 I squared. Okay, so the next term, so we have the I to the 4. Well, I to the 4, that's just I squared times I squared, which is minus 1 times minus 1, which is positive 1. So I to the 4 is just 1. So our next term, the 15 out of the 4, that's just plus 15. Okay, now what's I to the 5? Well, I to the 5, that's just I to the 4 times I. We just calculated I to the 4 to be 1, so this is just going to be 1 times I, which is equal to I. So this minus I to the 5, that's just really just minus I. Okay, so now let's simplify. So what do we have? So we have a 243, a minus 270. Oh, let's do one more. Let's combine those right now. And then a 15. So what's that? 243 minus 270. And then plus 15. That's minus 12. We have a minus 405i. And then also a minus I. So that's going to be minus 406i. And then also we have this term. So we have a minus 90 times minus 1 times I squared. But really what that is, well, that minus 90 and minus 1, that just becomes plus 90. And then we have I squared, but we know I squared is minus 1. So that's really just 90 times minus 1. Sorry, minus 10 minus 1. Okay, so now what does this equal? So we have minus 12 minus 90, which is minus 102. And then minus 406I. And so this will be our final answer. That's actually good for this section. Okay. Yeah, so we could stop here for the day. I'll have to, add the homework onto Canvas in a second. I'll make a little homework sheet because this chapter 8 homework, I believe, is due on Sunday. Yeah, so I'll do that. Yeah, other than that, we're all good for the day. So I'll, see you guys tomorrow for the next video. Cool. Thank you.